What is Kubernetes? Kubernetes originates from Kybernetes, Greek for helmsman, pilot, or governor. Kubernetes is an open-source container orchestration system. This definition might be a little abstract, so let's analyze its different parts. First, we need to understand what a container is. In an operating system, a process is defined as a set of instructions of a program, its execution state, and the associated resources. By means of the operating system, the process has access to a part of the available physical resources provided by the underlying hardware. Normally, processes running on top of an operating system have visibility on each other. A container is defined as a mechanism that isolates a process or a set of processes from the rest of processes running on the operating system. Besides, each container includes the files and dependencies needed by the process to run. Thus, using containers is usually referred as operating system level virtualization. Speaking about virtualization, what's the difference between a container and a virtual machine? In the traditional virtualization model, the hypervisor acts as the intermediate element between the virtual machines and the physical hardware. Each virtual machine contains an operating system alongside the binaries, libraries, and applications it runs. A virtual machine's content can be packaged into images to ease its distribution. However, when using operating system level virtualization, just one operating system is used, on top of which the containers run. Each container has access to the common components exposed by the operating system kernel. Thus, containers are much lighter than virtual machines, as the operating system is not packaged within the container, and it just contains the applications, libraries, and binaries needed for its execution. In order to execute containers on top of the operating system, an intermediate layer is needed, the container runtime or container engine, which executes the containers. There are several implementations. Some of them are Docker, CRI-O, or Rocket. Like virtual machines, containers are generated from images. Therefore, once the image has been generated, it can be easily distributed and run in any host which has a container runtime. Container images are stored in a specific type of repository known as image registry. The container runtime fetches the images from those registries. And here comes the big question. Why do we need orchestration if we already have a container runtime which takes care of the containers? The answer is simple. In production environments where high availability has to be guaranteed, several nodes or virtual machines are used, each one running its own container runtime. In this situation, a lot of different questions start to come up. How to guarantee that containers in different nodes can communicate with each other? How does each node know which containers run in the other nodes? How to select the best node to run each container? How do we guarantee that a container is restarted when it fails? And if a node runs out of physical resources, how to guarantee that containers are run in other available nodes? The answer to these questions and many more is the same: Kubernetes. Kubernetes allows to aggregate and manage effectively and in a simple way node groups which execute containers. Besides, it provides ideal capabilities for cloud-native environments, such as autoscaling, allowing the applications and nodes to scale based on the traffic and load, as well as a highly available architecture. At the application level, Kubernetes provides load balancing capabilities, service discovery, storage orchestration, resource management at container level, and health status monitoring for the applications in the cluster. Furthermore, it provides utilities to automate application deployments and rollbacks. If you want to learn more about Kubernetes, cloud computing, and containers, you can visit cubesandclouds.com and europeclouds.com.